Abstraction and modularity are fundamental concepts in programming that allow for the creation of more organized, efficient, and maintainable systems. Modular design involves dividing a program into smaller, self-contained components, known as modules, which can be developed, tested, and modified independently. This facilitates the understanding and management of complex systems, as each module focuses on a specific task, allowing developers to work in a more organized and efficient manner. Within this approach, functions play a key role as they allow for the encapsulation of reusable blocks of code that perform specific tasks. The concept of a function in programming not only implies code reuse, but also a structure that facilitates the orderly execution of a program. A function in C++, for example, is defined by a declaration or definition that specifies its name, the parameters it can receive, the type of value it returns, and the block of instructions it executes. The function call process is executed when it is invoked from another part of the code, and during this process, parameters can be passed by value or by reference. The difference between these two types of parameter passing lies in how the information is handled within the function. By value, a copy of the data is passed, while by reference, the memory address is passed. This entire mechanism of modularity and abstraction ensures that programs are easier to maintain, extend, and debug, thus improving the long-term quality and sustainability of the software.